Good evening, students. In the previous session, about current electricity, we already discussed about what is electric current and flow of charges, about electrical resistance, Ohm's law, and this combination of resistors, series combination we discussed in last session. Now today, first I am going to discuss about a parallel combination of resistors, and then I will continue with some numericals problems here. I will end up with numerical problems, circuit problems, etc. Now, first, in a series combination, just to recall this series combination of resistances. If you have two resistors in series, we have taken like this resistors in a series. If you take R1 and R2, if they are in a series connected with a battery of a potential difference V, battery of potential difference V, and when current I is flowing through this, then we know that voltage across the first resistor we can take as a V1, voltage across second resistor is V2, total potential difference, net potential difference in the combination is V is equal to V1 plus V2. By taking V1 plus V2, at the end we got equivalent resistance R equivalent is R1 plus R2 when two resistors in a series, right? For n resistors in series, equation is R equivalent is equal to R1 plus R2 plus etc. up to Rn. This is the equivalent resistance for n different resistors in a series. For n identical resistors also I have given. For n identical resistors, if our resistors are same value, identical resistors, then we can write R1 equal to R2 equal to etc. R values are same. Simply I will take R. If there are n number of resistors, R equivalent can be written as R equivalent R plus R plus R plus R plus R. There are n number of R's, so the total we can write as n times R, correct? N times R. This concept we can use in the combination of resistors, circuit diagrams, circuit solving, etc. We can use this. Next, now I am going to take parallel combinations. How we can get equivalent in parallel combination? It's a detailed derivation I have already discussed in previous session. Now I will take a parallel combination of resistors. Parallel combination of resistors. Parallel combination of resistors. Parallel combination of resistors. I will take two resistors in parallel. Three resistors also similar method, but for simplicity, I take two resistors in parallel. That is resistor R1 and another resistor R2. These two resistors in parallel. They are connected between two common terminals with a battery. This is a battery of potential V. This is a positive, negative terminal of the battery. Current will flow from positive, negative direction. I is the current. Now, students, here, if you connect in a parallel combination, this total current, what happens at this junction? This is a junction here. At this junction, what about the total current? That will split in two branches, right? Current must split here, correct? Total current is I. Here current will split in these two branches. Like this, current will split. It will split, right? Now what I can write this one, split current, I will take as total current I will take this as I1, this current as I2. Current will split here, I1 and I2. But what about potential difference? See, this first resistor R1, this is connected across battery of potential V. Second resistor R2, that also connected to the same battery. Between two common junction here. These two are common junction. I'll take this junction as A, this point as B. Between two common terminals A and B, I have connected two resistors R1 and R2, so that potential difference between two resistors R1 and R2 is the same. That is, here also potential is V, and here also potential is V only. Correct? Is it clear? Potential is V, but current is different, resistance is different. Now I have to get equivalent resistance of this combination. That means instead of two resistors, I have to replace one single resistor. Its equivalent value is equal to equivalent of this circuit. That I have to do here. Correct? Now first we have Ohm's law. Based on Ohm's law, what is the equation here? Ohm's law. Ohm's law states potential difference is directly proportional to current provided physical conditions same. That is, V is proportional to I or V is equal to R into I. I'll write V is equal to I into R. V equal to I into R. What is I? I is equal to current. Current I is equal to V by R. I is equal to V by R. Using current I is equal to V by R, I can write total current. Total current, that is I is equal to total current I equal to I1 plus I2. Total current I equal to I1 plus I2. I1 I can write as I1 as V is the potential difference, R is the resistance here in the first branch. First branch of this circuit, resistance R1, current is I1, resistance R1, so that I can be written as V divided by resistance R1. Resistance R1. Is it clear? Next I2. How I can write I2? Resistance in this branch is R2. Potential difference is V. Potential difference is V. So that V divided by R2. This is the total current I. I will take this as equation 1. Equation 1 I can take. Correct? Next, I have to replace this. What is my aim? Aim is to replace these two resistors into a single resistor. Its value must be same as these two values, two resistors. So that I will replace this with equivalent circuit with a single resistor with the same battery V. Battery potential is V only. It sends the same current I. Resistance is R equivalent. R equivalent is the resistance. Now what is the potential difference across this resistor? V only. V is the potential difference. Now for this second circuit, I can write current I is equal to potential difference is V. What is the resistance here? R equivalent I have taken. R equivalent is the resistance. I will take this as equation 2. Now you compare first and the second equation. First equation I is equal to V by R1 plus V by R2. This is for first circuit. And its equivalent circuit I have taken as R equivalent value of resistance. Now for the second circuit I is equal to V by R equivalent. Now you can compare these two. Left hand side is current is same. Why current is same? I have used the same battery of potential difference V. So that current is same. Current is same, right? Voltage is same voltage. Someone is asking their question. Voltage is the same battery, same potential, current is same. So that I can compare these two from equation 1 and equation 2. From equation 1 and equation 2, left hand side is the same, so that right hand side must be equal. I can write V by R equivalent is equal to first equation V by R1 plus V by R2. Is it clear? I just what I did here, just equated equation 1 and equation 2, right? Now numerator, you look at numerator here. V. This V I can cancel throughout. V. You can cancel. Then what is remaining? Remaining is, I'll write here 1 by R equivalent equal to 1 by R1 plus 1 by R2. This is the equivalent resistance. Or we can simplify that. I can simplify this by taking LCM. By taking LCM, I can simplify this as, our original equation is 1 by R equivalent is 1 by R1 plus 1 by R2. You take LCM here, R1, R2, numerator R1 plus R2. Reverse this, reverse. R equivalent is R1, R2 divided by R1 plus R2. This is a simplified equation for equivalent resistance when two resistors in parallel. In a series we got R1 plus R2. In a parallel we get R1, R2 by R1 plus R2. Suppose I take three resistors. How I can write equation? If I take three resistors. If I take three resistor, I can write this equation as for three resistors. Then what happens? Total current will split into three branches, right? Three branches. Total resistance will, I have to add the I1 plus I2 plus I3 I have to add, correct? So that V by R1, V by R2, V by R3 I will get. That is, if three resistors in parallel, then our circuit becomes first resistor, second resistor, third resistors in parallel. Hope you can understand. I will connect with the same battery V. I will connect. Students, if you have any doubts, any clarification required in between, you can ask. Okay. Now I will take a same current I, same battery, same current. I will take a resistor R1, R2, R3 resistance. Now in this case, so current, what about current? Total current I will split into these three branches. If I take I1, I2, I3, total current becomes I1 plus I2 plus I3, right? I equal to I1 plus I2 plus I3. So that if I use equivalent circuit for this as single resistor R equivalent with the same battery V, current I, potential difference here is V. For that second circuit, I can write first and second circuit together. I will write first. I is equal to V by R equivalent equal to V by R1 first resistor plus second resistor V by R2 plus third resistor V by R3. Is it clear? V by R3. Numerator V. We can cancel. What is remaining? Remaining becomes 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. சரியா? Correct, no? This is the equivalent. Hope you know how to take LCM. Take LCM R1, R2, R3 in the denominator. Numerator we get, simplify, you get the equation. Now here How to write? If you want, I will simplify this further. Taking LCM, this can be written as 1 by R equivalent is R1, R2, R3. Numerator what happens? R1 is here, so that what I have to write here? R2 plus R2, R3. That is R2, R3 plus next R3, R1 plus R1, R2. Correct? R1, R2. This is the equation we get. Is it clear? Yes. Any doubts? If you have any doubts, you can ask. Hope you understood this. Final equation, you can reverse this. You can reverse this. Just R equivalent is R1, R2, R3 by R1 plus R2, R1, R2, R2, R3 divided by plus R3, R1. You can simplify that. Suppose you take n identical resistors. N identical resistors. Then how to write? If I take n identical resistors, if I take two identical resistors here, R, what happens this equation? R plus R, 2R, 2R. Then how to simplify this? How to simplify this? If it is identical resistor. Yes, any doubts? Any doubts? Yes. Say, for 3 resistor, what I did here is 3 resistor. You look at once again. 3 resistor in parallel. Instead of 2, I have taken 3 here. This one is clear, right? Next, it's a equivalent. Instead of 3, I will replace one single resistor, R equivalent. R equivalent single resistor. This is our requirement. R equivalent we have to find. Okay. Now you check here. Total current I in this circuit is I1 plus I2 plus I3 is the total current. I is equal to I1, I2, I3. That is the total current I here. Current entering in this junction that will split into these 3 branches. That is I1, I2 and I3. This incoming current here is I1. Total current I. This I will split as I1 plus I2 plus I3. Correct? Is it okay? I split into I1 plus I2 plus I3. Now that I have taken here, I is equal to I1, I2 and I3. Now what is the I? I is the total current. I is the total current. Total current, this I is equal to, I'll write here for first circuit separately. I is equal to I1, I2, I3. I1, I2, I3 I'll write as V by R1 plus V by R2 plus V by R3. V by R3. Is it clear? This is okay. This is for first circuit. Is it clear? Some are asking you have doubts, not understood. Just to check this. This is for first circuit. I is equal to I1 I have taken as V by R1, I2 V by R2, I3 V by R3. Now it may be clear, right? This I will take as equation 1. Equation 1. Next, the second circuit. For this second circuit, I will write as I is equal to V divided by R equivalent is the current. Take this as equation 2. Equation 2. Now it may be clear. You take equation 1 and equation 2. That is what I have given here. This is combined equation 1 and 2 combined here, that is substituted. Substitute equation 1 and 2 here. Equation 2 is V by R equivalent. Equation 2 V by R equivalent, and this is equation 1. Equation 1. This is equation 1. This is equation 2. Is it clear? Now numerator V cancel. You get 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. Now hope this is clear now. Now taking LCM, that is a common process. That is common for everyone, right? That comes in mass LCM. Now if you reverse this, we get R equivalent for 3 resistor is R equivalent is R1, R2, R3. Same equation I am rewriting, but reverse way. That is R1, R2 plus R2, R3 plus R3, R1. Is it clear? Now I will take a n identical resistor. For n identical, if I first for simplicity I will take 2 resistors. For 2 identical, then it will be more clear for you. 2 identical resistors. If you take a 2 identical resistor, this will be easy for you. What is R equivalent? R equivalent is R1 R2 by R1 plus R2 equivalent equation. That is R into R by R plus R. R plus R. What do we get? 2R square divided by 2R. 1R cancel. What is remaining? R by 2. R by 2. For 3 resistors, 3 identical resistors, for 3 identical resistors, for 3 identical resistors, what I can write? R equivalent is R into R, same equation I am writing here. R into R, that is R into R plus R into R plus R into R, substituting here. R1 is equal to R2 is equal to R3 is equal to R only. Yes, someone is asking where we have to use formula. I will explain where we have to use. I will give the example questions. I will give based on circuit. We can solve that. R plus R. This is R square. Here R cube. We get R cube denominator R square plus R square plus R square. How many times? 3 times. 3 times here R square. That is R cube divided by 3R square. R square and cube cancel. R cube. 1R remains here. What we get? That is R by 3. Correct? R by 3. Now if 3 identical resistors connected in parallel, we get R by 3. 2 identical resistors in parallel, R by 2. If there are n number of identical resistors in parallel, what we get? For n identical resistors. For n identical resistors, how I can write? For 3 resistors, R by 3. For 4 resistors, R by 4. For 5 resistors, R by 5. For n resistors, R equivalent is R by n. Correct? R by n. This is an important relation for n identical resistors. This we can use to solve circuits. If we have identical resistors, I will give example, students. If you want more clarification, I will give some circuit examples. First, I will solve some exercise questions. Your NCERT, some exercise questions I will solve first. Then I will give the more application of these circuit problems. Then it becomes more clear for you. First, I will take your circuit experiment. This NCERT exercise. Some questions are there in your NCERT. First, I will take. See, here is one question. This question is in your NCERT exercise. If you have your textbook, you can check this. A copper wire has diameter 0.5. I will explain how to simplify this kind of questions. Okay. Now here a copper wire has a diameter 0.5 millimeter. That means the diameter is given 0.5 millimeter is the diameter. This is given here, diameter. This first I have to use SI system. SI system. In SI system, diameter, this millimeter is given. I have to write in meter. That is a 0.5 into 10 power minus 3 meter, millimeter to meter conversion. Next, what is given? Resistivity is given. Resistivity is 1.6 into 10 power minus 8 ohm is given. Resistivity, what is the symbol we used? Specific resistance or resistivity. What is the symbol? Rho. Rho is resistivity 1.6 into 10 power minus 8 ohm meter given in SI system. This is the resistivity value. What will be the length of this wire? Length of the wire. This we have to find, right? What will be the length of the wire to make its resistance? Your resistance value is given. Resistance value is 10 ohm. Resistance value R is 10 ohm. 10 ohm. To get 10 ohm resistance, what will be the length of this wire? To get 10 ohm resistance. And second, one more question is there. How much does the resistance change if the diameter is doubled? That is, if I change the diameter d dash, I write 2 times d. I will change the diameter. Next, second question. How much does the resistance will change? That is R dash. I have to write R dash. This I have to write. Okay. Hope you understood the question. What is given? First, you read the question, read the problem. What is given, you have to understand first. I noted all this data, given data. Diameter is given, resistivity is given here. Length we have to find for this particular resistance. Now, students, what is the relation? Hope you remember the relation between resistance and resistivity, including length and area. Hope you remember this equation in the second class. I think we derived R equal to rho L by A. Hope you remember this equation. Hope you remember, right? R equal to rho L by A. What is area? Area is equal to pi r square. Area equal to pi r square radius. But in this question, radius is not given. How to get that radius? Radius is not given. How to get a radius? What is given? You check here. Diameter is given. Diameter is given. How to get radius? Diameter by 2. That is the radius. Diameter by 2. First I will find that using diameter. Radius, I will write here. Radius R equal to diameter by 2. Diameter by 2. Yes. Diameter value is 0.5. That is 0.5 into 10 power minus 3 by 2. It is a 0.25 into 10 power minus 3. Is it clear? 0.25 into 10 power minus 3. This much meter is the radius. Now I got radius. Using this radius, I get a area. I will get area. Students, I will derive this. I will simplify this. So together, instead of solving a separate calculation, I will do this together here by substituting area directly. It saves our time, right? Okay. First, I will substitute here. I have to find out a length. I will rearrange this first. L equal to, rearrange this. So take area here. R into area divided by rho. Area is a pi r square. Pi r square. I'll substitute directly. Resistance is given. I have to get a 10 ohm resistance. 10 ohm resistance into area. Area is a pi r square. Pi. What is the pi value? 3.14. Pi is 3.14. Pi is 3.14 into r square. R square, how to write? R square. R square is R into R is R square, right? R into R, that is 0.25 into 10 power minus 3 into 0.25 10 power minus 3 minus 3 2 times. I will multiply that. Okay, 22 by 7 also we can use pi value. 22 by 7 or 3.14. I will use 3.14 instead of 22 by 7. That is easy methods. See, 22 by 7, that is a 3.14. 22 by 7 is 3.14. Some students are saying 22 by 7. I will use 3.14. This is better. I can simplify faster by using this. See, I will show you how to get that. Resistivity rho is given here 1.6 into 10 power minus 8. 10 power minus 8. 1.6 into 10 power minus 8. Correct? I substitute it here, all the data. Now I will show you how to simplify this faster. Okay. See, 1.6 I have in the denominator. To simplify, instead of multiplication, better you have to cancel as much as possible. If you cancel, once you cancel all the terms, maximum terms, then you go for multiplication. That is the easy way. First, I will go for cancellation method. If wherever possible, you cancel all those terms. First, 1.6 in the denominator, you check this. We have 3.14. 3.14 nearly 3.2 if I take 1.6 double 3.2, right? 1.6 nearly double if you take double, 3.2 is a double, this is nearly 3.2, so that 1.6 once times this 2 times I can write nearly, not exact, nearly I can take this. If I take this 2, now I can simplify easily. 10, what is remaining? 10 into 2. See, one step I'll write 10 into 2 into 0.25 into 0.25 into 10 power minus 3, 10 power minus 3. Total ಎಷ್ಟಾಯಿತು 10 power minus 6. 10 power minus 3, 10 power minus 3, 10 power minus 6. And the denominator we have 10 power minus 8. This minus 8 if you take to numerator, what we get? Plus 8. Plus 8. 10 power plus 8. Denominator vanishes. Correct? Now you get the answer easily. See, 0.25, 0.25, how much? 25, 25, 625. 0.25, 0.25 is 0.0625. 10, I'll take 10, this 10, I'll combine with this, so 10 power 9. This 10, 10 power 8, 10 power 9, 10 power 9 and 10 power minus 6. 10 power 3, 10 power 3, 10 power 3, I will write here into 10 power 3, last I will write 10 powers. All 10 powers simplify together, 10 power 3, then what is remaining? 0.25, 0.25, 0.0625, 0.0625 into this 2, correct? This 2. Multiply this 0.625, 6 to double 12, 6 double 12, 12, 25, 5, 12.5 we get. 12.5, 12.500, 10 power 3 if you take, you get a 12.5, 125 we get, nearly 125 we get. 125 meter. Correct? Nearly 125 meter. Nearly 125 meter, students. This may not exact. There may be this is exact, but here I have taken approximation here. If you do this calculation in calculator, there will be small change in this number 125. Instead of 125, you may get 122 or 123. That is okay. That is okay, because with approximation we got nearly equal. This is how we can solve this question, any problems, numericals without calculator. Without calculator, we have to simplify. With the calculator, you get exact number, but without calculator, we can solve any big numbers. We can easily solve, easily simplify. What we have to do is first, as much as possible, you cancel the terms nearly. Then all 10 to the powers you make it together, 10 to the powers you combine together. Remaining you multiply. Multiplication must be minimum, so that we can get answer easily. Students, hope you understood this. How to get an answer for this question. Hope you understood. If you have any queries, any doubts, please give the comment. If no doubts, I'll move forward for next question. No doubts, right? Yes. There is another question. This is a graphical question. Plot the graph. This plotting we need a graph sheet, right? Graph sheet. Plotting we need a graph sheet. Graph sheet is not possible here. See, plotting method. Hope you know how to plot, but without a graph, I can't solve this. I have to solve this using graph sheet, and you have to solve this using graph sheet. What is required here is to plot the graph between you and calculate the resistance. How to get resistance I can tell you, but exact plotting is not possible here because no data. Graph sheet is required here. Now here if you take in a graph, I will tell you how to plot this graph, I can tell you. Okay. If I take a V versus I graph, I will take I here, I, current I and voltage graph. Current I will you have to write a scale here at 0.5, 1, then this is 1.5, this becomes 2, 2.5, then you take 3 here, extend 3, next 3.5, next I have to take a 4, correct? This kind of graph we have to plot. It's easy, yes. Someone is saying this question is easy. If we are not understood, you have to represent this number here in y-axis. Then you get a graph like this. Take slope, take slope. This is delta V, delta I along x-axis. This number distance we have to find out, and resistance R is equal to delta V by delta I. Delta I we have to write. Delta V by delta I. This is a resistance we get. Okay. Hope you can do this using using graph. If someone is saying last question is not completed, yes, I will check once again. What is remaining? What is remaining there? Yes, last part. How much does the resistance change if the diameter is doubled? Yes, yes. One part is pending. Someone remembered. Yes, thank you, Pratiksha. One more part is remaining. That is, how much does the resistance change if the diameter is doubled? That is the last question, correct? Last question. Resistance, what happens? What is the resistance and diameter relation? Diameter double means, so what about radius? Radius also doubles, right? See, diameter doubles means diameter is 2 times d. What about radius? Radius also doubles. Radius also doubles. That is, radius becomes radius. Radius r dash becomes 2 times initial radius. 2 times initial radius. Diameter doubles means radius also doubles. Correct? If radius doubles, so what is the resistance and radius relation? I will go for this equation. You check this equation. See, from this, resistivity length remains the same, only resistance is doubled, so radius is doubled, so that resistance R is inversely proportional to area. Use proportionality concept. If you use a proportionality concept, you can easily simplify, but resistance is not doubled, students. Someone is saying resistance is doubled, resistance is not doubled. See, what is the relation for resistance and area? Radius double means area also changes, correct? But area is not doubling here. What happens? Area becomes 4 times. I will show you how it changes. See, I will rub this part here. See, area, what is area? Area is a pi r square. See, I will use this same concept. Area is a pi r square, but pi is a number, constant. Pi is constant, so that I can write resistance R is proportional to R square. I can write, correct? Resistance is inversely proportional to R square. Is it clear? Now, what about R dash? R dash is a double here, 2 times. R dash is equal to 1 by R dash square, small r dash square, that is a 2R square. Is it clear? 1 by 2R square. 1 by 2R square means 1 by 4 times R square. What is 1 by R square? Is R. 1 by R square is R. So that R by 4 I can write. R by 4. R by 4 means, so what is R dash? 1/4, right? 1/4, correct? 1 by 4. What is answer? 1 by 4 is the answer. It is a 1/4. 1/4. R by 4. R by 4 means 1/4 is the answer. What is the answer for this? How much does the resistance change? Resistance change by how much? Resistance change by 1/4. Correct? 1/4 is the answer. Last question, answer is 1 by 4. Is it clear? Now question is complete, no? Everything is complete. Yes. Next question over. Next, when 12 volt battery. Say one more question. This is also NCERT exercise question here. NCERT question. Say in this question, when a 12 volt battery, say what is given? 12 volt battery is given. 12 volt battery is given. 12 volt battery means potential difference V is 12 volt. 12 volt battery is connected across an unknown resistance. Resistance is unknown. I'll write R. We don't know R. Unknown resistance. Comma, there is a current of 2.5 milliampere. Current of 2.5 milliampere. Current I is 2.5 milliampere. How to write milliampere to ampere? Milliampere to ampere, 10 power minus 3, right? 10 power minus 3. 10 power minus 3, right? That is a 2.5 minus 3 ampere. Now what we have to find? Find the value of the resistance of the resistor. We should find resistance of the resistor. That is a unknown resistance value we have to find. Unknown resistance value R we have to find. It is a very simple, right? Very simple question. Very simple exercise question. We have to find R resistance by using Ohm's law. Direct from Ohm's law, right? This you can write. Simplify the student. Students, simplify that. Simplify and try to get the answer. How to get R is equal to resistance R equal to V by I. Substitute these data and simplify. You get answer easily. Answer easily you get. Just to take 10 20 second you can answer. Just 20 seconds. Yes. Anyone? RSV by I, as someone is trying there. Pratikshayam. 4800 ohm. 4800. Someone is saying 8 into 10 power 3. 4800 may be too much. Yes, maybe 4800 ohm, right? 10 power minus 3 goes numerator 4s. Correct. That answer is correct. Answer is correct. See, V is 12 divided by I is current. Current is 2.5 into 10 power minus 3. First, what you have to write? 12 by 2.5. 12 by 2.5, how much? That is, see, simplification method is 12 by 2.5. 12 by 2.5 is 4.8. Correct? 4.8. 10 power minus 3 you take to numerator. 10 power minus 3 numerator into 10 power plus 3. This much ohm is the resistance. This is the resistance. Is it clear? 4.8 into 10 power plus 3 ohm resistance, or 4.8 10 power plus 3 is a kilo ohm, right? We can write 4.8 kilo ohm. We can write kilo is 10 power plus 3 is a kilo. Correct? Yes, good. Someone answered very well. Yes, many answered correct answer. Yes. Next, I will go for next question. This is a easy question, right? Next question you check. Next question. See, a battery of 9 volt is connected in series. Some resistors are given. A battery of 9 volt is given. Correct? 9 volts. First, what I have to note down? I have to note down potential difference. V is a 9 volt. 9 volt I have to note. Correct? Next, what I have to given? What is given? See, series with resistors 2, 3. See, number of resistors I'll check. 2 ohm, 0.2 ohm, 0.3 ohm, 0.4, 0.5 and 12 ohm. Total 1, 2, 3, 4, 5 resistors given. How it is connected? They are connected in a series. Read the question carefully. All these 5 resistors, they are in a series connection. Right? A series connection. Series connection. Next, how much current would flow through the 12 ohm resistor? 12 ohm resistor. That is required. Correct? First, I have to take this. All these are in a series. First, one resistor, total 5, 2, 3, 4, 5. Correct? This I will write as 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm, and this is 12 ohm. 12 ohm. This is in a series with a battery of voltage. Battery voltage is 9 volts. 9 volts. This is the application of series combination. Series combination of resistors. Now current I is flowing, but a current through each resistor is the same, right? Current through each resistor is same. Why? Because it is a series combination. It is a series combination. In series combination, current through each resistor is the same. Now, first what I have to write? Equivalent of these 5 resistors I have to find first. What is equivalent? R equivalent is R1 plus R2 plus R3 plus R4 plus R5. There are 5 resistors. R1, you take this as R1, R2, R3, R4, R5. 5 resistors are there. 5 resistors in a series. What is the equivalent resistance? R1 plus R2 plus R3 plus R4 plus R5, right? Equivalent resistance. Now I will add directly 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. Total how much? Total how much? Tell me first. 5, 9, 12, 14, 13.4, is it 13.4? Is it 13.4, right? 13.4 ohm resistance, right? 13.4 is 13.4 total, yes, 13.4 ohm resistance. Now I have to get a I current I. What is the current I? I is equal to V by, for equivalent resistance. What is the formula given? I is equal to V by R equivalent. R equivalent. V is given. V is a 9 volt. 9 divided by 13.4. 13.4. 9 by 13.4. What is 9 by 13.4? Solve this quickly. 1 point something we get. 1 point something. 9 by 13.4, 0 point, 0 point, 0 0.6, 0 0.67, yes, right, 0 0.67 we get, 0 0.67, is it clear? 0 0.67, yes, 0 0.67, right. This is a circuit current. Circuit current, say students, what they have given is current through 12 ohm resistor given. But what is the current through 0.5 ohm resistor? Same. Current through each and every resistor in this circuit is the same because they are in a series combination. They simply they asked for 12 ohm. Whatever the value of resistor given, current through each resistor in series combination is the same. You can write, suppose they ask a question, what is the current through 0.4 ohm resistor? Answer is same. What is the current through 0.5 ohm resistor? Answer is the same, right? Same answer. That is I is 0.67. But in a parallel they ask, value will be different. In a parallel, current through each resistor is different in parallel combination. But series combination, current through each resistor is same. Okay, this you understood, hope, correct? Someone answered well, correct answer given, many students. Yes, I'll go for next question. Say, this is a good question, correct? How many 176 ohm resistors? How many 176 ohm resistors? That is a resistance value is 176 ohm is given. In parallel, see, you look at this question carefully. In parallel, we have to connect a parallel combination, are required to carry 5 ampere current. Current in the circuit is 5 ampere and 220 volt line. See, mains connected is 220 volt. 220 volt line, 5 ampere current. Correct? 5 ampere current. Now what should be the equivalent resistance? Now we need a total number of resistors. Correct? How many 176 ohm resistors required? That is number of resistors required is number of resistor is required. Number of resistors n is required. This is the required data. That is the question. Correct? Is it clear? Yes. Now how to simplify this? To simplify, you understand the question first up. We have to do parallel combination. Current is given, voltage is given. Now what resistor we have to connect to this? To get 5 ampere to 20 volts. That I will write first. R equal to V by I. It is a basic Ohm's law equation. Now what is the potential difference given? 220 volt and current required is 5 ampere. This gives you 220 divided by 5. 220 by 5, how much? 40, 44, right? 44. Is it clear? 44. That is a 44 ohm resistance we require. Correct? 44 ohm resistor we require. By using 176 ohm resistor, how many resistors we have to connect to get 44 ohm? I have given one a simple. Someone asked earlier, what is the use of that equations? Parallel combination. While I am deriving, someone asked their question. What is the use of that these equations? Now you have the use of this equation. What equation I have given there? For n identical resistor, for n resistors, at the end last I have given that R is equal to R is equal to R by N, correct? For N identical resistor. Equivalent is, if I use equivalent, R equivalent is R by N. This equation I will use now. This last equation I will use. Now N is equal to, that is N is equal to, N is the number of resistors required. Resistance value divided by R equivalent. R equivalent. Now what is the equivalent value? 44 ohm. 44 ohm is the equivalent. That is R is 176 by R equivalent is 44. What is the 176 by 44? It is a 4, right? It is a 4. Now what is the number of resistors required? 4 resistors. I have to connect 4 resistors in parallel. If you connect 4 resistors in parallel, what is the equivalent? Equivalent is 44 we get. Equivalent is 44. Correct? This is a reverse way I can simplify in short. To solve this question in short, we need this last equation. That is a shortcut equation. At the end I have given. Using this shortcut equation, you can easily get this number of resistors. Is it clear? Very easily, quickly we can solve this answer. Is it clear? Hope many students understood. We are given correct answer there. Correct answer given. 4 resistor is given. So that answer is 4 resistors. 4 resistors are required. Is it clear? If you understood, if any other question is there, I will go for that. Yes, one more question is there. One more question is there. That is the show how show. See, show. We have to prove here how you would connect 3 resistors. 3 resistors, each of resistance 6 ohm. We have 3 resistors there, number of resistor 3, and each of resistance 6 ohm is there. So that the combination has a resistance of 9 ohm and another combination has a 4 ohm. 4 ohm. We have identical resistors there, correct? 6 ohm resistance and 3 resistors are there, all 3 identical resistors, 6 ohm resistor. Now equivalent, how much we have to get? 9 ohm equivalent we have to get. 9 ohm equivalent we have to get. If you connect in a series R1 plus R2, if you connect 2 resistor in a series, 2 resistors in a series, then equivalent what happens? 6 plus 6 12, but we need only 9. Then to reduce the value, we have to go for a parallel combination. To reduce the value, to decrease the value, we have to go for a parallel combination. Now I will use a parallel combination first. If I take 2 resistor in a parallel, then what is the equivalent? 6 ohm here, 6 ohm. Now I will use, once again I will use a shortcut equation. I have to get this equivalent of this 2 ohm, 2 resistors, identical resistors. If 2 identical resistors, what is the equivalent? R equivalent is R by N formula. R by N formula. What is the N here? N is 2. If N is 2, what is the equivalent of this? Equivalent of this 6 by 2, that is 3 ohm. 3 ohm. 3 ohm is the equivalent. Now this is 3. How much I have to get? 9. I will take another series 6 ohm. series 6 ohm. Now what is the equivalent between A and B here? Equivalent between A and B, two ends I will take. Resistance across AB is this. What is the equivalent of this? First two resistors, 3 ohm, 3 ohm plus it is series 6 ohm, total 9 ohm we get. That is answer for first question. Answer for first question. Is it clear? This is the answer for first question. Very simple. If you understand this combination, series combination, you get a answer easily. I will use that last concept R by N here, R by N. If you use R by N, quickly you can tell the equivalent of this. Equivalent of 6 and 6 is 3 by 2 by 2, 3. And this 3 and this 6 is in a series. So that what happens? 6 plus 3 is 9. Okay. Next I have one more question. One more question. What is that? Equivalent I have to get is 4 ohm. I have to get 4 ohm equivalent. 4 ohm equivalent. How to get that 4 ohm equivalent? Series we get parallel. I have to write parallel. I have to reduce from 6, right? I will take 1, 2, 3 in parallel. How much equivalent? If I take 3 resistor in parallel, what is the equivalent across this? 6 ohm, 6 ohm, 6 ohm. Again use the same concept. Again use same concept. 6 by 3 now. 6 by 3. Equivalent. What is equivalent here? R equivalent is 6 by 3. R by N formula. R by N formula. 3 resistors. 6 by 3 is 2 ohm here. Equivalent of this is 2. I have to, how much I have to get? I have to get 4. 2 plus 2 is 4. Is it clear? 2 plus 2 is 4. How to get 2 plus 2? I already I got 2. One more 2 I have to get. How to get one more 2? See, take this 3 ohm resistor once again. Once again, I will take this is B, this is A. See, first 3 resistor 2 ohm. Next 3 6 ohm, 6 ohm, 6 ohm. What is the equivalent of this? Equivalent is again 2 ohm is equivalent here. Now this 2 ohm and this 2 ohm in a series, all three in parallel S. This 2 ohm, this 2 ohm in series, correct? This 2 ohm in series, what is the equivalent? Equivalent R series or RAB. RAB is 2 plus 2, that is a 4 ohm we get. This is 4 ohm. This is the answer. This answer for second. The question is show how we can connect this combination. How we can make the combination of 6 ohm resistor, so that we get 9 ohm here and 4 ohm. This is how we can connect. 9. This is how we can connect. Hope you understand this concept. Any doubts, students? If you have any doubts, I will clarify. Only this much question is there. Okay. Next, power concept we have to discuss. Power, electrical energy and electrical power concept we have to discuss. After discussing that, questions related to electrical power I will do. Hope there is no doubt, students. I will end up this session here. If you have any doubts or any queries, you can clarify in next session also. Okay. Thank you.